we were asked to plot the polar coordinate points 4 pi over 3 and minus 5 minus pi. And so let's just begin looking one by one and seeing what we have. If we look at 4 pi over 3, this means that the radius is 4 and the angle is pi over 3. Pi over 3 is a third of the way across from the positive x-axis to the positive to the negative x-axis. So that actually corresponds to 60 degrees. So we're actually looking at something which is 60 degrees up here. So that's 2/3 of the way up from the x-axis to the y-axis. This one looks like it's about appropriate. This one is not. There's nothing in that range. So if we're looking at the first two, then it's either B or C as far as 4 and pi over 3. We also need we need it to have a radius of 4. It's not obvious from the picture that this necessarily has a radius of 4. That means length, right? So this line segment has to be 4. It's not clear whether or not that's the case for now, but really what we're going to be looking at is these angles. Is this angle pi over 3? Yes. But what about the next value? -5, negative pi. -5, negative pi. So let's look at the angle first. Negative pi means that we're at an angle of negative pi. Negative pi, angle of pi is actually all the way over here, right, and along the negative x-axis. Negative angle means that you reverse the way you're looking. So negative pi is actually the same thing as 0. So an angle of 0, which is the positive x-axis. So this one has to be pointing in the positive x-axis. So the only one that has the pi over 3 angle the correct way and the negative pi angle the correct way is choice B. There's a second part. You have two alternate sets of coordinates for 4 pi over 3. Now, there's a couple of ways that we can get alternate coordinates. If we have an angle and we add 2 pi to it, then that means that we get back to exactly the same angle. So let's again look at our picture. So if we have an angle, if we have this at pi over 3, and we add 2 pi to it, we get all the way back to where we started. So we can either add 2 pi or subtract 2 pi, and we're going to have the same point. Let's see if any of those options are given. So pi over 3 plus 2 pi, well 2 pi is 6 pi over 3, so we're looking at 7 pi over 3. So if we have a 7 pi over 3 and a 4, that's good. This is another option. The radius hasn't changed, and we're 2 pi away from where we used to be. So that one is okay. This one is not, because if we go 2 pi forward to 7 pi over 3, then the radius should be exactly the same as it is. So this one's out. This one is a possibility. Let's look at the other ways that we can get this. Another way that we can get to the same point with different coordinates is by adding pi. If I add pi, then I'm 180 degrees over, so I've moved this way, but then changed the radius value to negative. So if I were down here and then had a negative radius, then I'm back over here. So pi over 3 plus pi, well, pi is 3 pi over 3, so pi over 3 plus pi is 4 pi over 3. If I have a 4 pi over 3 for the angle, but a negative 4 for the radius, then we'd also be okay. Right, so 4 pi over 3, I don't see any of those with 4 pi over 3. So those are not going to be okay. But what else could we do? We could actually take our given, so far I was liking C, so let's look at this one and see what's happening, to see if it's okay or not. Negative 2 pi over 3. What is negative 2 pi over 3? Well, negative 2 pi over 3 is actually the opposite way to get to exactly the same point. If I subtracted pi, if I took pi over 3 minus pi, that's pi over 3 minus 3 pi over 3, which is negative 2 pi over 3. So a negative 2 pi over 3 angle, but then a negative radius will get me to exactly the same thing. And that's what we see right here. Negative 2 pi over 3 for the angle, so that's 180 degrees back, and then negative 4 means a move in the opposite direction, and it puts us back to exactly the same point. And then also for the last one, a negative 5, negative pi. Again, if I add 2 pi to the angle, I get exactly the same point. So adding 2 pi to this is a pi. None of those are pi, but I could also subtract 2 pi, moving the other direction. If I subtract 2 pi, I get negative 3 pi. But that won't change the radius value. So this one is out. So negative 3 pi is out. None of those are out. If I add 2 pi to this, I get to pi. Adding 2 pi again gets me to 3 pi. But I shouldn't change the radius in that case. So part B is out. What else could we do? We could move by pi and then change the radius. Right, so if I move this by pi, then I'd change this to 0, but that would change the radius to positive. So I like this. 0 for an angle, positive 5. That's exactly the same as this. So I've changed this by pi, 180 degrees, but then also changed the sign of the radius to undo that change. So that one's good. And then if I add 2 pi again, I get back to something that's exactly the same. So changing the angle by 2 pi means don't change the radius. So these two are actually equivalent. Since this one is equivalent to this, choice D is the right answer.